So wonderful question again about some pretty big words. So we have regiochemistry, we have peroxy carboxylic acid, and we have epoxidation. So let's start by defining those things. So I'm going to the IUPAC Gold Book, and I just want to show that regioselectivity is which direction does a bond make or break. Which direction does it go preferably over all other possible directions. So kind of as just a really quick example, although this doesn't cover everything like methyl shifts, for example, but in general, we can kind of think about how the, oh, come on, Apple Pencil, the, maybe it's because it's not all the way in. Ho ho, yes, okay, we're back. So effectively, you can kind of say to yourself, well, if I have an atom 1 connected to atom 2, and again, this is a simple case. There are some other ones where we can think about, well, what he's describing here doesn't really define all versions of regioselectivity, but for this student's question, I think it does. So atom 1 and atom 2, we can either have the electrons go on to atom 1, the red arrow, or we can have them go to atom 2 in the blue arrow. And so that's what regioselective is, but how is it applied to this student's question? Well, we're talking about a peroxy acid. And so in this case, we're looking at something that has this OOH group. Little unique, we might not have seen it before. So now we have O1 connected to O2 in this group, and we can ask ourselves, well, does the electrons go like this when the nucleophile attacks, or do they go like this when the nucleophile attacks? And so again, I just want to remind us that the last part of this is an epoxidation. We're effectively using a nucleophile that will create an epoxide. And so in this case, typically it's the alkene that's going to be attacking this group to form the epoxide. And so what we have here is now the answer to the student's question. So what I need to think about is, okay, I have O1, as we've previously kind of defined, and I have it connected to O2. And please excuse the not ideal geometry. Come on, we can do that. We're going to allow this. And we're going to ask ourselves, okay, what happens if my nucleophile comes in, attacks this oxygen, and the electrons follow this one possible pathway of bond breakage, right? To remind ourselves, this is what I'm focusing on, the direction that a bond breaks. Well, what result is this? Well, we're going to have the result of the COO going to this anion, okay? And if this is a comparison, well, let's look at the other result. So again, I'll kind of redraw this very interesting reactant, O1, O2 going to H. And in this case, well, we'll think about the blue bond breakage. So a nucleophile comes in on the O, the electrons go onto O2, and we are now left with an OH anion. And so this begs the question of, well, which pathway? Is it the red pathway or is it the blue pathway? There are two results. Oh, let me show you what I got here. There are two results for what's possible. So which one is the more preferential pathway over all other pathways? Well, if you've watched other videos before about resonance or stability of anions, that's what's driving this force. We need to consider for ourselves molecules' reactions. Almost all of life is about going to the more stable state, the more accessible state. And so if we have the choice to put a minus on one O versus a minus on the other O, there doesn't seem to be a difference. But we've learned that resonance can stabilize a molecule in ways we might not at first suspect. Thank you, p orbitals. And so what we're seeing here is that this is how the bond breaks. It's these regioselective bond breaking that does happen. And how do we understand it? By saying that the resulting anion is more stable. So there is a driving force for access to stability to give us the bond breakage that we see here. So I hope that helps with that learning objective. If not, as always, comment below if you still have questions, or comment if there's an error in the video. And we'll keep the discussion going there, and maybe I'll upload a new video.